When we talk about function notation, what function notation allows us to do is name different equations, or specifically functions. Okay? So don't get caught up in all the words I have listed here. I want to focus on a couple things. Okay? Let's look at this equation here. Y equals 3x plus 2. Now, this is a function. If we were to graph it, it'd be a straight line. It'd pass the vertical line test. For every input, there's exactly one output. Now, what we can do, though, is we can name this function. Okay? And it basically, what we're going to talk about here is we have the symbol f of x. It replaces the y. So instead of writing a y, we're going to write this f parenthesis x parenthesis. Now, the way we read that is value of f at x, or simply f of x, and that's what you're going to hear me say. It does not mean f times x. Okay? This names the function 3x plus 2 as the f function. That way we could take another function. Let's say we had y equals negative 2x plus 5, and maybe we could call that g of x. That way the function has a name and we don't have to write it out every time. We could say the g of x function, the f of x function. Okay? And normally we use f, g, and h's for functions. Again, it doesn't mean multiplying. We are just naming the function. It works the same as y. All we did is we replaced y with f of x. So we're not changing how we're doing any of the problems. It's just a different notation. And that's all that's really difficult with this, is we're so used to like solving for y and everything. It's hard to have a different notation. But the cool thing about function notation, as you're going to see in a second, is a function notation gives us more information. Okay, let's talk about what I mean. It says evaluate the function with the given value of the variable. F of x equals 7 minus 3x when x minus 4. I'm sorry, with x equals 4. This is the same thing as if I said y equals 7 minus 3x. How would we solve it? Okay, well, if I have y equals 7 minus 3 times x, and well, x is 4, I'm just going to substitute 4 in for x. Y equals 7 minus 3 times 4. 7 minus 12, which equals a negative 5. We know how to do that problem already. So don't get confused by this f of x. Okay? What this f of x does is we treat it the same way. We want to know what f of x is when x equals 4. Now here's the cool thing about this. Put some different colors in here to show you. Okay, get rid of my x's here. I'm sorry, not getting rid of them. I just want to put them in a different color. Okay, we're still going to replace 4 for x, but what we can do now is we could say, all right, what is the function f at 4? Because we want to then just figure out what's 7 minus 3 times 4. Okay, and I'm just putting it in different colors so hopefully you can kind of see that all we're doing is replacing the x with 4. We still do the problem the same way. 7 minus 12 is still going to be a negative 5. But what we get now is f of 4 equals negative 5. Before we had y equals negative 5. And when you're just given this piece of information, great, we know what y is. Y is negative 5. The cool thing about function notation is now that we know what x is too. When I inputted 4, I got out a negative 5. So now we could see the total picture. Our input of 4, our output is negative 5. Okay, and that's the power of function notation. We treat it the same way as if it was y equals, but if it said y equals, we don't know what we inputted to get negative 5 unless we went back to the question. With function notation, it tells us what our input was and what our output is. Okay? The same thing is true here. Look at part B here. We want to know what f of x is. F of x equals, if I can correctly draw an x here, f of x equals 10x plus 3. Okay, so we're going to say f of x equals 10 times x plus 3. And it wants us to do it when x equals negative 2. Okay, so we're going to say f of negative 2 equals 10 times negative 2. We're just substituting it in just like we would before, plus 3. Okay? So now we're going to have f of negative 2 equals negative 20 plus 3. F of negative 2 equals negative 17. Notice we didn't do anything with the f of negative 2. That's just our y. We just substituted negative 2 in and we calculated the answer. But again, function notation says, all right, now I can see my input. What did I input to get a negative 17? I inputted a negative 2. And that's important for when we're going to figure out slope in a second here. Okay? So again, when we're evaluating functions and function notation, you treat it the exact same way if it was y equals. But function notation allows us to see the input and the output. Okay? Now, if we had to graph in function notation, the first thing you do is you just substitute f of x with y. And I'm going to change this to plus and negative 4. Okay? Remember, f of x replaces the y, so you can replace the y back in for f of x. Now, if you look at this, once you replace that f of x with y, this is slope-intercept form. So we graph just like we've been graphing. What is my y-intercept? Negative 4. So I come down here to negative 4 and put a dot. What is my slope? 5, so we'll write as 5 over 1 for rise over run. And I rise 5. 1, 2, 3, 4, 5, and I run 1. There's my new point. So now if I'm going to draw this line, I just draw it through these 2 points. So don't stress when it says graph and function notation. Just take that f of x out, replace it with a y, and use slope-intercept form to graph the exact same way you've practiced in the past. Okay? Again, these are interchangeable, f of x and y. Alright, now a second ago I talked about finding slope. It says find the slope of the graph of the linear function f. And now we're given this information and your first thought is probably, I can't find slope, I don't have enough information. Well, remember, slope is the difference in our y's, y2 minus y1, over x2 minus x1. Okay, go back here. Remember I said what function notation allows us to do is it tells us what our input value is and what our output value is. Our input is our x value, our output is our y value. So remember, this is like saying f of x equals negative 1. So the 6 is our x. This is actually the point 6, negative 1. And if that totally doesn't make sense, just trust me. It's saying the function at 6 is negative 1. Our input is negative 6, our output is negative 1. Our x value is 6, our y is negative 1. So when you look at it that way, you have 2 points. If you have 2 points, can you find the slope? Sure. Call this x1, y1, and this x2, y2. Again, notice we already know how to find slope. Notation is different, but the way we do things is the same. So I'm going to go 8 minus a negative 1 over 3 minus 6. Keep, change. 8 plus 1, 3 minus 6, or 3 plus negative 6 is going to be negative 3. 8 plus 1 is 9 over negative 3. 9 divided by negative 3 is going to be a negative 3. So if it says what is the slope, well, our slope is negative 3. Okay? This is something you already know how to do. Be aware when you're given it in function notation though, whatever's in parentheses here, remember your f of x, that's your x value, that's your input, and what it equals is your output. That allows you to find out 2 ordered pairs, which lets you find the slope.